The National Electrical Code, or NEC, typically requires that electrical receptacles be installed with the grounding terminal at the bottom. This configuration is designed to help ensure proper grounding and electrical safety. The primary reason for placing the grounding terminal at the bottom is to facilitate a direct and reliable connection to the grounding wire. When the grounding terminal is at the bottom, gravity assists in maintaining a secure connection between the grounding conductor and the receptacle. This is especially important in cases where the receptacle is subjected to vibration or movement, as it reduces the likelihood of the grounding connection becoming loose or disconnected. Moreover, the bottom placement of the grounding terminal helps to minimize the risk of accidental contact with energized parts. If a conductive object, such as a metal tool or a piece of wire, were to fall onto the receptacle, it is less likely to come into contact with the hot or neutral terminals if the grounding terminal is positioned below them. This design feature provides an added layer of safety for users and helps to prevent electrical shocks. In the event of a fault, such as a short circuit, the grounding system provides a low impedance path for the fault current to return to the source. This low impedance path allows the circuit breaker or fuse to quickly trip, de-energizing the circuit and preventing a dangerous buildup of voltage. If the grounding system is not properly installed or maintained, the fault current may not be able to flow quickly enough, which could result in a shock hazard or even a fire. The NEC provides detailed guidelines for the installation and maintenance of grounding systems, including requirements for the size and type of grounding conductors, the bonding of metallic enclosures, and the testing of grounding connections. These requirements are designed to ensure that the grounding system is able to effectively protect people and property from electrical hazards. While the NEC generally mandates the bottom placement of the grounding terminal, there are some exceptions to this rule. One notable exception applies to receptacles installed in wet or damp locations. In such environments, the grounding terminal is required to be placed at the top. The rationale behind this exception is to prevent water from entering the receptacle and compromising its electrical integrity. With the grounding terminal at the top, any water that manages to seep into the receptacle is less likely to come into contact with the energized terminals, reducing the risk of electrical shock. Furthermore, in certain specialized applications, such as in hospitals or healthcare facilities, specific requirements may dictate the orientation of the grounding terminal based on the unique needs of the environment. These specialized requirements are typically outlined in the NEC or other relevant standards and regulations. When encountering a receptacle with the grounding terminal at the top in a standard, dry location, it is reasonable to suspect that it may have been installed incorrectly. However, it is essential to consider the possibility of exceptions or specialized applications before making a definitive judgment. Consulting the NEC or a qualified electrician is always recommended to ensure compliance with applicable codes and standards. Grounding is a critical aspect of electrical safety, and proper installation of receptacles, including the correct orientation of the grounding terminal, plays a vital role in protecting people and property from electrical hazards. Firstly, always disconnect power to the circuit before working on any electrical components, including receptacles. This can be achieved by turning off the circuit breaker that supplies power to the receptacle. Secondly, use a voltage tester to verify that the power is indeed off before proceeding with any work. Thirdly, carefully remove the receptacle from the electrical box, taking note of the wiring connections. Fourthly, inspect the wiring for any signs of damage, such as frayed insulation or loose connections. Fifthly, if you are replacing the receptacle, ensure that the new receptacle is of the same type and rating as the old one. Sixthly, connect the wires to the new receptacle in the same manner as they were connected to the old one, paying close attention to the grounding wire. Seventhly, securely mount the new receptacle in the electrical box. Eighthly, restore power to the circuit by turning on the circuit breaker. Ninthly, test the receptacle to ensure that it is working properly. And tenthly, if you are not comfortable performing electrical work yourself, it is always best to consult a qualified electrician. It is important to note that electrical codes and regulations can vary depending on your location, so it is always a good idea to check with your local authorities to ensure that you are following the correct procedures. The NEC is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law, but it is widely adopted by state and local governments as the basis for their electrical codes. This means that in many jurisdictions, compliance with the NEC is mandatory. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. The code is written in a clear and concise manner, making it relatively easy for electricians and other qualified individuals to understand and apply. However, it is important to note that the NEC is a complex document, and a thorough understanding of its provisions is essential for ensuring electrical safety. One of the key principles of the NEC is to provide a safe and reliable electrical system that protects people and property from electrical hazards. This is achieved through a combination of prescriptive requirements and performance-based standards. Prescriptive requirements specify exactly how certain electrical installations must be performed, while performance-based standards allow for flexibility in design and installation as long as the system meets certain safety criteria. The NEC also emphasizes the importance of proper grounding. Grounding is the process of connecting electrical equipment and systems to the earth, providing a low impedance path for fault currents to flow back to the source. This helps to prevent electrical shocks and fires in the event of a fault. The NEC contains detailed requirements for grounding, including the size and type of grounding conductors, the bonding of metallic enclosures, and the testing of grounding connections. Overcurrent protection is another critical aspect of electrical safety that is addressed in the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to automatically interrupt the flow of current in a circuit if the current exceeds a safe level. This helps to prevent damage to electrical equipment and wiring, as well as reducing the risk of electrical fires. The NEC specifies the size and type of overcurrent protection devices that must be used in various electrical circuits. Wiring methods are also covered extensively in the NEC. The code specifies the types of wiring methods that are permitted in different applications, as well as the requirements for installing and supporting wiring. Wiring methods include conduit, cable, and other types of raceways. The NEC also addresses the issue of voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC specifies the maximum allowable voltage drop for various types of circuits. Electrical equipment installation is another important topic that is covered in the NEC. The code specifies the requirements for installing various types of electrical equipment, such as motors, transformers, and lighting fixtures. The NEC also addresses the issue of hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC specifies the types of electrical equipment that are permitted in hazardous locations, as well as the requirements for installing and maintaining this equipment. The NEC is a living document, and it is constantly being updated to reflect changes in technology and best practices. The NFPA publishes a new edition of the NEC every 3 years, and it is important for electricians and other qualified individuals to stay up to date on the latest changes. The NEC is an essential tool for ensuring electrical safety, and compliance with its provisions is critical for protecting people and property from electrical hazards. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include state and local codes, as well as standards promulgated by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of all of the applicable standards and regulations when designing and installing electrical systems. Proper grounding is absolutely vital to electrical safety.